Hello everyone again. My name is Philippe Ozil, and I want to thank you for having me. Thanks you to the organizers, and thank you for attending. It's a great pleasure to give you my talk about platform events. I'll be talking about two things, platform events and event-driven software architecture. And this is going to be lasting about 40 minutes. Some of the slides are very technical, so I will be able to adapt the content on demand if it's going to be, if it's too technical, I can skip some slides. If it's not technical enough, I can even comment more. I have a great deal of experience with platform events, so I can adapt. It's not the first time I present this talk, so I can improvise a bit. I am a Salesforce employee, so I do have to show you this traditional slide about the forward-looking statement. Because we are a publicly traded company, please do not make any purchasing decisions based on what I'm going to show you in these slides. Only make your decisions based on what is commercially available in the product. Now the good news is that everything in this presentation is already available, so I shouldn't be making forward-looking statements. My talk is going to be divided into two parts. First of all, I'm going to talk about event-driven architecture outside of the context of Salesforce, just in general. And then I will focus on platform events. That's really the Salesforce part. So I'm going to start with something high level in terms of architecture. And here we go. So what is event-driven software architecture? Well, it's a concept that is based on real-time event notification. It's sending events from something called publishers to subscribers. So the way it works is that the events that it's sending are actually sent in a one-way mode. They're actually fire and forget. There's never a response. If you look compared to a traditional HTTP request, in an HTTP request you got a client which sends a request and then the server gets a response back. And with event-driven, it's only you fire an event and that's it. There's no response. So this allows it to be very fast. And it also allows it to have another benefit. It decouples the client or the subscriber from the publisher. The publisher, the one who fires the message, does not need to know about the subscribers because in the middle there's something called an event bus. And I'm going to describe this publisher-subscriber model in the next slide. So in short, event-driven software architecture is good for two things. It's good for decoupling when you have a lot of things that you want to integrate. It breaks the tight coupling between the different components. And it scales also because it's really meant to handle large loads because there's no bidirectional communication, I would say. The main concept of event-driven architecture is based around the publisher-subscriber model, or pub-sub. You may have heard of it. During the presentation, I will talk about events, but sometimes I will also say messages, because we also call this a message bus. It is the same thing. So don't worry if I mix the two terms. Events equal messages, in short. So in the center, at the core of the architecture, we have the event bus, or the message bus. On one side, we have the event consumers. So these are the components or the applications that are listening for signals, for messages, for events. The event consumers will actually register on the event bus. They actually know the address of the event bus, and they will say, okay, I'm interested in this particular type of information. They select what they want to listen to. And then on the other end, you have event producers. So of course, the event producers can be one of the event consumers, or it can be something else. But the event producer is basically capable of firing a message or an event. To do that, it publishes on the event bus. The producer does not know about the consumers. It only knows about the event bus. That's what makes the decoupling, basically. Everybody knows about the event bus, but there's no point-to-point connection other than that. When an event producer publishes a message to the event bus, what happens is that the event bus is intelligent enough to find what are the active subscribers. So it will actually broadcast to any listening consumer which has subscribed to this particular type of message. That's how, in short, pub-sub model works. Now let's compare a bit this architecture with something more traditional. Let's compare it with, for example, request-driven or service-oriented architecture. Here I've given you an example with basically an e-commerce solution with different modules, different services, shops, payment, customer database, etc. And all of these services are actually tightly coupled or integrated because they rely on each other. For example, the shop needs to connect with the inventory and the customer database. And there are other examples. The problem with this type of directional architecture is that when you want to change a service, let's say we want to update the customer database to a new version, we change a bit the definition of the service, we want to extend it, maybe we add a loyalty program, something like that, we want to update it. If we do that, there's something called the ripple effect that will affect all the connected services. So that means in the end, we have to update all of these other services, almost the entirety of our solution. So that's the main problem behind coupling or with request-driven or service-oriented architectures. To limit that, we have event-driven architectures. So with event-driven architecture, instead of having multiple point-to-point connections between the different services, we only have the event bus in the middle. And with this system, we can have versioning in terms of messages, and we can still handle all messages at the same time. This allows us to break the coupling between the different services. Now let's see an example. Here we have again our event-driven architecture, and let's see, for example, if we issue an order, how does this work? For example, if the shop has an order, it will fire a message or an event to the event bus, and then the event will be propagated to the integrated services that rely on this event. Now, what is interesting is that when you talk about event-driven, you have to change a bit the way you think. Event-driven works in the past tense to be accurate. So we are not actually triggering action. We are actually signaling that something has happened, and then we can work on the consequences of that. We are not actually requesting a particular action. So the order events actually, an order has happened, and then we need to update the other services. It's not like I'm requesting an order. That's an important set of mind, basically, that you need to adapt when you work with that, because you're not triggering or targeting specific services, so you're not issuing out requests or actions. If you do work with actions, you're like basically trying to create the request-driven service, so that's not exactly what you want to do here. Now enough with the theory. Now let's skip now to the Salesforce part, and let's now work on the core of this presentation, platform events. So platform events were introduced in summer 17. They're not exactly new. It's almost been a year now. We've updated them in winter. There were a few additions to the model. I'm not going to cover those in the next slides. Does someone here has already used the streaming APIs? Or is it something totally new? Yes, at least. Okay. So I will have some slides comparing it to the streaming APIs, because there's a lot of similarities between those two things. I'll see if it's too technical or not. But it is relying on something that existed previously. It's an evolution, basically, of the streaming API. It could kind of replace it. There are a few features that are really similar. Now, the platform events are really the way to deploy an event-driven architecture, because it also relies on the publisher-subscriber model. We're going to see the same architecture diagram we saw previously, updated with the Salesforce different components. The advantage of using the platform events is that we provide different ways to interact with those. We can either use them in a declarative ways, meaning that you can use them with clicks, or we can have full code approaches. And this is very flexible because you can mix and match those two kinds of methods to consume and produce messages. Another advantage of platform events is that they are actually typed, they're strongly typed. So when you send a message, you can have attributes on those messages, and you're actually assigning specific types to fields basically in these objects. I'll give you some more details on that. Another thing that is, lastly, a really main focus of events, it's based on real-time communication. So there is no persistence. We do not store these messages in memory. I mean, we only store them in memory. We don't write them to a disk. So these messages, these platform events, cannot be queried. There is no way to write a so-called query to search for particular events. There's also no user interface to list all the events that occurred. It's your job to actually write down the interface if you listen to something, and maybe write them yourself as a custom object, but by default they're not stored. The only way to get a message when you missed it is actually to use the replay capability. You can replay any message that happened in the last 24 hours. We're only keeping them in memory for 24 hours. That's a strong limitation. There's no way of changing that.
But I'm sorry, it's on the side of subscriber or of producer to reply this message?
So the subscribers can replay the messages that were interested.
Which is on the bus?
Yes.
Right? Okay.
So it's up to the subscribers to replay them?
Yes.
There is no menu to monitor all the events?
There's no UI to do that, yes. And I will talk about the replay capabilities. You will have several pointers on how to replay things. Let's see a few use cases for those. Well, the first one, it's a bit ambitious, but it's a way to provide microservices. Now, to be honest, you're not going to deploy microservices inside Salesforce, but you could be deploying microservices with integration, which is the second point. You can delegate some of the processing power if you have long-running operations on an external platform like Heroku or another dedicated platform. For example, if you have to do image processing, document processing, something a bit heavy that could actually hurt your limits, you can delegate this to an external platform and use platform event to do the synchronization between this external system and your Salesforce platform. So in the end, it's the main focus of platform events is for integration. It's really good when you have to communicate between multiple platforms, multiple technology stacks. And it's also good when you have to do real-time communication, like IoT, multiple devices sending a lot of information back, and also mobile devices, because you have, for example, push real-time notifications that you can do with that. In the end of the presentation, I will talk about my experience, also the latest experience I had with platform events. I've been to TDX and I've actually built a demonstration using a lot of platform events. It's not part of the presentation, but I will talk about that after. Now, I mentioned that I will be comparing platform events with the streaming API, so for some of you it's going to be new, for the others it may sound familiar. The streaming APIs are actually divided into two subtopics. They're actually the push topic and the generic messages. And depending on which one you talk about, they have different constraints. So let's compare all of those three things. Let's start first with the data structure. For platform events, I mentioned that earlier, when you have a platform event, you define typed fields. So you actually define pretty much like a custom object. You assign different fields with different types. For push topics, it's a whole different story. For push topics, you're basically writing a so-called query, for example, on accounts or custom objects. And then when the result of the so-called query changes, it will automatically fire a platform a push topic. So the structure of your push topic is defined by the so-called query you write. So for example, if you select name from account, your push topic will only contain the name. And when the result of the query changes, you fire a push topic. For generic, it's pretty unstructured. You have about 2,000 character string that you can put whatever you want in. Generally, you put JSON in, but you can write whatever you want. And there is no way of telling if the structure of a generic streaming message is the same from one instance to the other. So it's powerful, but it's also a bit dangerous if you change the structure between different publishers. There's no guarantee that it will be always the same structure. Then, in terms of publication mechanism, for platform events, it's the most flexible approach because you can use clicks or a code to publish a platform event. For the streaming API, you cannot actually manually fire a push topic. It's only fired when the so-called query that creates the push topic changes. And for the generic streaming API, it's only through code, and that's using REST API. That's the only option, so it's a bit limited. So that's why platform events are actually bringing a new bringing more capabilities to the platform. For propagation, most of these type of events actually support the broadcast mode, and there's a specific mention for generic streaming API, which allows to send the message to specific subscribers. You can target a few subscribers if you know them. That's a bit against the principle of publisher subscriber because you can target specific subscribers, but that's an option. And last, for the way to subscribe to those messages, platform events are also declarative code, but the streaming API only works with code. So to keep it short, if you want to use streaming API, the only option basically is to use code because you can only receive them with code, and you have to use something called the Bayeux client. I will talk more about the Bayeux client. This is basically what supports all of these streaming events, whether it is the platform events or streaming API. That's the backbone of the way we send those messages to subscribers. Now let's take one step back and let's get back to platform events in general. So I mentioned that we follow the publisher subscriber model, and let's see how it works on the Salesforce platform side. In the middle we have the platform event bus. So this is already within the Salesforce platform. On one side we have the publishers. We can publish platform events either through external apps or within the Salesforce platform. And depending on where we are, we have different methods of publishing those messages. For example, if you're using external apps or if you're within the Salesforce platform, you can use the APIs. Be it SOAP, REST, or the bulk APIs, you can fire platform events. If you are within the CSS platform, you can also use Apex. I will give you some examples of the code that we use to fire a platform event. And lastly, if you're also within the CSS platform, you have the declarative tools like in Process Builder or Visual Workflow. By the way, Visual Workflow will be renamed to Cloudflow Designer. That's the new name. Cloudflow Designer. Cloudflow Designer. That's the new name for.
On name will change, or
They're probably bringing also some updates. I haven't kept up to date, but that's an announcement we made at TDX.
Yeah.
I do believe they try to get rid of the Flash thing, which is the good news. So that's yeah. Also, there's a lot more connections with Lightning. Yes. So these are the three options you have for the publication of messages. And then on the other end, you have subscribers. Same story. You can use external apps or the platform to subscribe to messages. So you could really have specific scenarios in which you could fire a platform event within the platform and also subscribe to it within the platform. It's not very interesting in terms of architecture, but it's possible. Then, if you are using something that is outside of Salesforce or within Salesforce, you can use the Bayeux protocol again. And there are different implementations. The protocol is something that is just a standard, and you have to use software that follows this standard. You can use 3 different libraries, at least in JavaScript, because most likely you're using JavaScript to receive those messages, but you can also use Java, whatever technology. The reference implementation for the Bayeux protocol is the first one. It's called CometD. I believe there is, of course, the JavaScript client, but there's also a Java client. And the 2 others, Socket.io and Fay, are actually also based on JavaScript. There are more than that. I'm not giving you a full list, but you want to use the Bayeux protocol. That's the way to receive platform events when you're outside of Salesforce.
So you mean that we can receive an event to the client directly?
Yes. So the client is the one that has the Bayeux protocol implementation to subscribe.
Yeah.
recently we had this problem that our client didn't have this protocol implemented. And because of that, we weren't able to use platform events.
Yeah, it's a really strong. It's mandatory.
Yeah.
I will talk a bit more about Bayeux protocol. Maybe it's very interesting. We also have the possibility, if we're within the CSS platform, to use Apex Trigger to react to platform events, and we can also use the declarative tools again. And this last part, the declarative tool to receive platform events, is actually the addition we made in winter 18. It wasn't possible when we first released platform events. You couldn't subscribe to them declaratively, but now we can do the full chain, sending them and receiving them with clicks. So it's really open to anyone, basically. Now, let's talk a bit more about the Bayeux protocols, the backbone of the streaming API and the platform events. So the Bayeux protocol is a push communication protocol. It means that the server pushes messages to a client. The client, of course, can be your web browser, but it can also be a server. So there could be like a Java server listening for platform events, for example. It is a one-way communication again, and all the content that goes within this protocol is actually encoded in JSON. So there's no binary data that is being sent. That's important. It's really basically high level as text. Back to the Bayeux protocol. So JSON is basically the format, and there are actually multiple ways to carry this message. So the Bayeux protocol is interesting because it has multiple transports. Ideally, you want to use the streaming transport, which is the best way to deliver the message because it's a one-way communication. But if the client does not support it, for example, if it does not support WebSocket, which is the default streaming transport, it will fall back to HTTP polling. And the polling transport is a secondary option. It's like a backup option, which is less preferred because it's less efficient, but it can also work. So that's a very powerful protocol because whatever your client is, it will work. Now again, the HTTP protocol isn't very good because it does the back and forth, and it's also using a lot of network traffic for nothing because most of the time there are no messages. So it's constantly looping for checks if there are messages. It doesn't scale, by the way. If you have a lot of clients using HTTP, it will not scale because it's going to do a lot of connections to the server for nothing. So that's something to do. Ideally, you want to use WebSockets, which is designated basically for push communication. So that's really the low technical aspect of platform events and streaming APIs in general. Let's go back to more general things. So I mentioned that the platform events are actually typed. It's very similar to the way you would create a custom object. There's a little difference. The record type ends with __e in its name. It supports read and write permissions. So if you have, for example, a profile or a permission set, you can secure it with permissions. You do have to be authenticated, by the way, to receive or send Platform events. I forgot to mention that. You have to get authentication. So you have an identity provider and you know who you are when you're sending events. This is how we apply those permissions. And then in terms of fields of this, for the Platform events, we're using just custom field with __c. We only support a limited set of types because we actually convert those types into JSON because the Bayeux protocol requires it. So we only support text, number, checkbox, date, and time. There's no support for relationships. There's no support for pick list, nothing like that. It's really basic things that can be converted to JSON basically. There's no way to send a file. You can only send a file by giving a URL, for example. That would be the way to do it. So that's the structure of Platform events. And there's also another thing. There's another field that is actually included in Platform events, which is going to be very useful. That's the replay ID, and this is where the replay capability kicks in. When you fire a given Platform event type, there is a counter called the replay ID. This replay ID actually increments over time. 1, 2, 3, 4, 5, 6. It's guaranteed to be unique for a combination of Platform event type, so the definition of record, plus the instance of the message, and it only goes on increasing. Then you have this 24-hour retention window. So everything that happens before that is lost forever. We're not writing it again. For example, here we will never be able to catch event 1 unless we have stored it somewhere else. We can say to the Platform event subscriber, I want to replay every event starting from event 3, for example. And you could replay all of them. And then if we don't know which was the last event we received, if we don't know the ID of the last event we received, we can also have this little trick here to say replay ID -2, which will bring back every messages from the last 24 hours. So this is true for Platform events, but it's also true for the streaming APIs. It's the same basic foundation for both. So that's the way where you, for example, if you have a mobile application, your mobile application goes offline and you're missing a lot of messages, that's the way to implement the replay capability. If you go back online, check if anything happened when we were offline. Ideally, you want to keep track of the last replay ID and the time when this message was received. But if you don't want to do that, you can just replay all of them, and then it's your job to do the deconfliction between what you have already received and what you missed. There's actually one best practice I'd like to give you for handling Platform events. The general rule is to keep those events definition very light. You don't want to have a lot of fields. You want to only store references to objects. So if you're targeting, I don't know, an account, or if you're targeting a lead or something like that, you don't want to copy all the fields of this object. You actually want to point to an ID. So you basically fire an event with only the object ID, a reference to your object, and later on you process this event when you receive it on the client side. Why do you do that? Well, you do that because you will actually query this object back and forth. So that's adding, of course, some processing. But what happens is that basically you have no guarantee that the object will not change from the time when you send the event to the time when you receive it. So if you're assuming that your Platform event is actually sending up-to-date data and the client receives up-to-date data, that can be a mistake. If your data changes by the time you receive the Platform event, data may have changed in the middle. That's why we only send reference IDs. Keeps the definition simple and also guarantees that your client will process the updated data. It's a really good way to ensure that. So that was, I would say, the general slide. Now let's go more into the technical aspect. I'm going to go with some code samples and I'll finish with a little demo. We saw there are different ways to publish Platform events. If you've played with custom object, basically you will find this very, very similar code to create custom events. The only thing that I would like to draw your attention to is this thing in circle in red. To fire a Platform event, we use event bus abstract class and a publish method. So here on the first lines, we have created a custom Platform event with one attribute, and we're actually using the event bus publish message method to publish this Platform event. Here we're only publishing one Platform event. The method also works with lists of Platform events, so you can fire more than one at the same time. It is interesting to fire more than one because the event bus.publish method counts against your DML limits. So you can group those if you want to do batch processing. And then there is also the save result, which is the same as when you create custom object, except remember that we are not saving it to the database. So the name is a bit tricky. We should have used another name, but it's the same object. We can check for errors when we publish the platform event. What this means basically is that the event was transmitted to the event bus. It doesn't mean subscribers have received it, but it means that it was correctly saved. This could go wrong, for example, if you hit your limit. You would have a failure here. Or if you weren't allowed to actually publish this particular message because of your profile or something like that. So it's really similar to the code to create a custom object. Then for subscribing, you can use an Apex trigger. Same thing, it's very similar to regular trigger. The only difference is that we only support the after insert. That's the only statement we support because you cannot work before, of course. But other than that, it works fine.
You can also use the after update, right?
You cannot update platform events, yes.
Yeah.
Oh,
So that's the only statement. It's only after insert. That's the
Yeah.
only thing we can work with on platform events. But the structure is really the same as a regular trigger here.
yeah, because the
So-
point is for receiving.
It's for receiving our platform events, yes. Then on the REST API side, well, it's pretty much like you're creating a custom object or custom record. It's S objects. You can see it's even stored under S objects. And then the name of your platform event. It's just a regular post with JSON with the structure of the object. There's really nothing specific here. I'm not going to spend too much time. I just want to show you how easy it is to create platform events. Then let's get to the hard part. The hard part now, listening to a platform event with JavaScript when you're on a web client. This is a bit more tricky, so this I will spend more time on this one. Here I'm going to show you an example with JavaScript using a CometD client. So my example here actually runs on Lightning. It could run somewhere else, so it's already within Lightning. The first thing we want to do is actually configure the CometD client. To configure the CometD client, you need to specify the endpoint of the CometD server. It is exposed on the Salesforce URL with /CometD in the API version. Then we need to retrieve the library. So here in my example, it's sliding, so we have actually made reference to load the CometD script. We have included it as a static resource. We retrieve it with component get, and then we configure it. There are a few things to configure. Of course, the endpoint URL, then the authorization. I mentioned that to receive platform events, you need to be authenticated. So you do have to pass an OAuth token. You need a session ID. When you want to do that inside Lightning, you first have to call an Apex endpoint to get the current session ID, and then you can pass it as a header of the CometD message. And finally, the other type I'm not going to cover it. It's too technical. Then there's this bit here, which is very interesting because if you're running this code inside Lightning, we do not support direct connection to WebSockets within Lightning. So that's a limitation for now. For security reasons, we are not opening the WebSocket port within Lightning. So if you don't put this line in, what the WebSocket client, what CometD will try to do first, it will actually try WebSocket. It will see that it cannot connect, and then it will fall back to HTTP. So if you do forget this line, it will still work, but putting this line will actually save you time because it won't try to first do a connection that will fail. So it's a good thing to add it when you're in Lightning. When you're not running this within the Salesforce platform, you can use WebSocket perfectly fine. So you can just skip this line here, it's not needed. Then what we do is we actually authenticate with the CometD server. So we use basically our request with the OAuth token, and we check that we are allowed to connect to the server. If this works, we get a handshake reply. We can check if the handshake was successful. If not, we can of course handle the error. And then once we are connected to the server, we can subscribe to one or more platform events. And these are actually here the syntax to connect to these topics or the channels of the platform events. Here I'm listening for my events, it's a custom platform event. And then I have a callback. Each time there's a new message that is received, I will call this function here and, for example, log it on the console. That's the whole block of code we have. So this here is actually something you can find in Trello. There's a project about. I'll give you the link later on. This code you will find in the project. But first, now let me get to the demonstration. Okay, so what I'm going to show you here is actually based on one of the keynotes we presented. I think it was for last TDX when we introduced platform events. We've updated it a bit since, but the demo is called Northern Trail Outfitters. It's a fake outdoor clothing company. So they sell all sorts of items like jackets, backpacks, camping gear. So here I'm showing you just some items from the shop. This is just a jacket. And the way they work is they basically assemble mixes of their merchandise to send them to production to their marketing division, the manufacturing division. Sorry. So they just make bundles of their items. So I'm going to look at this bundle here. We have a winter collection, and we are actually assembling those items into a mix. So I have here a backpack, but I can add, I don't know, maybe like a tent here, and we have basically built the new collection with a few items there.
So,
Now, yeah.
The collection is used for what exactly? You mentioned
It is going to be used because we're going to send it to the manufacturing division for production.
Okay.
So we're just basically saying, okay, I need these items to be produced for my winter collection.
Okay.
So we assemble those items in a mix, and when we're ready to do that, we can move to the next step and actually send this mix to the manufacturing division. Now, the manufacturing division of Northern Trail does not run on Salesforce. They're actually having their own website. They're running on Heroku, or they could run on whatever. And oops, okay, squeeze that in. Here is their website. So I've minimized it a bit. It looks a bit ugly. This is the mobile version, but it's actually a bit better normally. Just put it back there. And when we are okay with our mix, we submit it to the manufacturing division. If I do that, I'll fire a platform event, and you can see that in real time, we have the mix that arrives to the manufacturing division. Now, if I go there, I'll find the details about my mix, same data that I have here. When the manufacturing division receives that, it reviews the item, gets ready to produce them, and then it says that it can produce those items, and proves it, and we'll fire back a platform event back to Salesforce, which updates in real time as well the status of the platform event. So what I just showcased here in like in a couple of seconds is the bidirectional integration between Salesforce and external systems. Here I've used Heroku, but it can work with any other application. The Heroku application is actually running Node.js, so it's nothing that is really tied to Salesforce. And there is a CometD client which listens to platform events, and it also fires platform events using REST API back to the Salesforce platform. So there were 2 platform events involved. That's how you can work with platform events. Now, if you want to go more into details, the technical way we do send the platform event here, when you click on the change status, is actually using a process builder. So I can actually show you that. If I go in setup and we check our platform events, our process builder, sorry. Here. When you look at our processes here, we have the mix status change, because when we change the status of the mix to submitted to manufacturing, we'll actually change the manufacturing to submitted, and then we'll call this X invocable method, which creates the platform event and fills up those fields with the value of the current object. And this is what fires declaratively the platform event. And on the Lightning components here, for example, on this path Lightning component, we have CometD client which listens actively for incoming platform events, and this is what will actually move the path to this particular step once we receive the platform event that has been sent by the Heroku application down there.
So both the applications are both
Listening and firing platform events.
publishers and subscribers.
Yeah, in this particular case, we are.
And all the field values and everything can be synced depending on what code you put in.
Yes, or you can send different information. Yes. So remember that we only keep identifiers, and we don't send the full, like we don't send the whole list of information about the items. We only send the IDs of the mix, and then we can query it back within the Heroku application, for example. That's how we would
And
do
I think the digital access, the images are but kind of a copy of the
The images are not even saved on set, so you just save on the Heroku, but just like a URL within the record. We actually saw that when we were in the mechanized section. There was a field, like I think this one, for example. There's a URL here which hosts the image. That's just the way it's implemented. It's not even a file on the Salesforce platform, but it could be, and you would have just to do an extra query to get it if you want to do that.
What do you define this event?
So let's have a look at the definition side. Back to setup. I'll need to go into platform events. Oops. Maximize this. There are a couple of events, and the one we're going to use is actually mix-approved, for example. And this is where you define. So you create a couple of fields. There are a few ones that are already available by default, standard fields, the date and the reply ID, which is the way to reply those messages. And then you can add custom fields there. You can also see some triggers. You can only see the ones that are on the Salesforce platform. You cannot see the subscription, sorry, but on the Salesforce platform, you cannot see the Heroku one because it is not controlled by this platform, the Salesforce platform. So the subscription view is incomplete. You would not see external platforms. You only see within the Salesforce platform. That's to be very clear. It's not mentioned anywhere, but do remember that it doesn't show third-party subscriptions. It only shows Salesforce subscriptions. To sum it up, we saw the principle of event-driven architecture. It's good for scaling again. It's good for decoupling. Very good for integrations and real-time communication. You can use platform events to support event-driven architecture within Salesforce. You can use it with codes or with clicks. It's very flexible. And yeah, it works fine with any kind of stack. So I've been working with maybe 3 or 4 programming languages. Each of them generally have a CometD client that is available or another Bayeux protocol client, so it's very easy to integrate with platform events. Now, if you want to get your hands on it, there are 2 things I'd like to recommend. There's a theoretical, just a module which is more about theoretical content about event-driven architecture and basic concept between platform with platform events. So that's Platform Events Basic. And then there's also a project, which is Hands-On Approach, which I actually wrote, about building an instant notification. On this one, on the project, you'll find the code that I showed you with the CometD client within the Lightning component. So if you want to build one yourself, feel free to reuse this code. It's up to you to grab it. And I'd like to share, just grab the name of the project and you can use it. Now, that's it for my presentation, so thanks for listening.